Use the sample data below with a significance level of 0.05 to test the claim that for the population of highest presidents and their main opponents, the differences have a mean greater than 0 centimeters. So presidents tend to be taller than their opponents. Think of this as Biden versus Trump. So this is the height of Biden and this is the height of Trump, the president and their main opponent. When we state the main opponent, we assume that it is a one-on-one match now. So this is a matched pair. President 1, his opponent. President 2, his opponent. President 3, his opponent, and so on. The heights are measured in centimeters and we assume normality. In this case, we do not need to check the condition because normality condition is met. Recognizing that this is the mass paired for the mean, we would find the difference in these data values. 189 minus 170 is positive 19, where we take the observation 1 minus observation 2. 173 minus 185 is negative 12. 183 minus 175 is 8. 180 minus 180 is 0. 179 minus 178 is positive 1. With Desmos.com, we bring up the table and we type in the data for the height of the presidents, 189, enter. This will take us to the next pair, 173, enter. 183, enter. 180, enter. 179, and then we would type the corresponding main opponents of the president. These are the height. 170, we need to type the corresponding height. We cannot mix them up. 185, they are pair. Perhaps it is better to type the first pair and then the second pair and so on. 175, 180, and lastly 178. We then go to the next column, which is the third column, and type in x sub 1 minus y sub 1. These are the differences in the two columns. And then we will specify the list. In this case, we call it L equals, open the brackets, and we type in these differences. Then we compute the mean by typing MEAN, open the parentheses, and we just bring in the list L. So the mean is 3.2. Similarly, we can compute the standard deviation by typing STDEV, the standard deviation, open the parentheses, and bring up the list L. The standard deviation is 11.4. In this case, the sample size n is 5, even though this is not greater than 30, but again, we can perform the test safely because we assume normality already. With these differences, we compute their mean, which is x sub d bar. X sub d bar is 3.2. Remember, to find the mean, we would add these 5 numbers up, get the total, and divide it by 5. The standard deviation of this sample of the difference is S sub d, and S sub d is 11.4. The first step in the hypothesis test is to state the null and the alternative hypothesis. The null hypothesis is the statement of indifference, so we assume the height of the president and his opponent is no difference, meaning mu sub d equals 0. We assume that the difference is 0. We assume that their heights are the same. For the claim, we assume that the claim that the difference have a mean greater than 0. So if mu1 represent the average height of all presidents, and mu2 represent the height of all main opponents. Then we're looking at the difference mu sub d equals mu sub 1 minus mu sub 2. And earlier we took observation 1 minus the corresponding observation 2, and so on. Because we want mu sub 1 to be greater than mu sub 2, not that we want, but we want to check if mu sub 1 is greater than mu sub 2, we would have to check the difference to be positive so that mu sub 1 is greater than mu sub 2. The next step is to compute the test statistic. The test statistic when the standard deviation of the population is not given is t. T is x sub d bar minus 0 divided by s sub d divided by the square root of n. X sub d bar is 3.2. The null value is 0. It comes from the null hypothesis divided by the standard deviation of the difference is 11.4 divided by the square root of n is 5. Put this in a calculator, we will get 0.628, and this is the test statistic. The next step is to compute the p-value. To determine the p-value, we need to know whether this is the left, right, or two-tailed test. From the alternative hypothesis with the inequality greater than, we know that this is the right-tailed test, and we computed the test statistic t equals 0.628, and so the p-value is only the probability that t is greater than 0.628, and using either a table or a calculator, we compute that the p-value is 0.282, where we use the degree of freedom 5 minus 1 equals 4. From this p-value, we compare it to alpha. Alpha is the significance level, and it was given 0.05. This p-value is greater than alpha, and so we would fail to reject the null hypothesis, meaning we support it. If we fail to reject the null hypothesis, then we would have to reject the alternative. But the alternative is the initial claim. And so, in the conclusion, we say there is not sufficient evidence to support the claim that for the population of heights of presidents and their main opponent, the differences have a mean greater than 0. In other words, presidents do not appear to be taller than their opponents. We reject the claim, the initial original claim.